My name is John Demarest, and my subject is going to be on machine learning. What machine learning is essentially is a program's ability to correct itself, right? So basically, it's almost like artificial intelligence, but it's not quite. It's fed and directed by the programmers, like myself. So essentially, what makes or breaks any kind of algorithm is the data collected. So say like for instance they have there's a new material that's coming out that I believe Harvard has just wrote a paper or published a paper about, was a conductive material that basically you could essentially spray it on anything you want, and you could make it touch compatible, right? So yeah, that sounds great, but there has to be an application behind there. And to simplify it, it has to be able to recall or remember a set of structures that it's given. So, as a programmer, let's say I'm building an app to make this conductive material fit for anything, just for an everyday user, no program, no programming experience, you're just essentially just telling it, yeah, this is what I want it to do, this is where I'm applying the material. So in order for me, the programmer, to be able to make this functional for the everyday consumer, I would have to have a set of structures that are fed through an algorithm that can do predictive inputs and outputs. So essentially, so if you want to swipe left, that means it's bad. But when you're spraying it to an area that there's no into, essentially, then you're you have to have a point of understanding where you're at for the program to understand. So essentially, basically what I'm saying is, let's pretend that the screen is what I'm talking about. So if we spray this screen and I just want to press here and swipe to the side, what I'm going to do as a programmer is say, okay, first touch the device, and swipe in the direction that you're calling left, right? So I'm going to take those points and I'm going to remember what that is, and I'm going to feed it through what we call essentially is a neural network, right? And I'm going to use a genetic algorithm to define and refine the data sets. So as I'm moving, yeah, there's a lot of points that's moving across. So I want to know, okay, well, what's the general concept? Is that it's a motion in a direction, right? So even if you're kind of, waving around, I want to capture the points as we're going, and I want to feed that through so that I have a predefined object to compare it to. So when you're saying left, this is what left means. When you're saying right, this is what right means. When you're saying up, this is what up means. And I can take what your movement is and essentially teach a device that has no clue what we're freaking talking about, and remember it and make it compatible across the board. And it's not only just that, it's like IoT, the Internet of Things, the interconnectability, right? So you want to be able to walk into your house and everything's controlled through your phone, right? Well, your phone wasn't built to control everything. Well, I mean, yeah, now we're getting towards that, but you can take older phones and be able to control your garage door opener, all sorts of things, just to be able to interconnect. And that's all a part of machine learning, because it's the processing of data to refine itself, to know what's right and wrong, and to decide the correct path, right? I mean, right here in the back, I have a 3D printer that has a, right? On this 3D printer, yeah, it's it's essentially stock from the manufacturer, but what I did was I took the original scope of the program that I was able to find off GitHub, and I inserted a genetic algorithm in it. So essentially what I want to see is every time I go to print this object, right, I essentially want to decrease the time, right? Not only to speed up the print, but to refine the print, to make the print better, higher quality, at a faster time. So, you're innovating a process just through thinking, allowing the machine to think. And it's such a broad theory or concept, but it's applicable because it's proven by math. And it's essentially what we are going to see in the future, when it comes to artificial intelligence itself. But it's all about defining the data structures and understanding what the data structures are and how to use them and why are we using them that way. And really, it's very much at its infancy, but I believe its gestation is gonna peak, really soon, because it's getting a lot of attention now. Just to think that 10 years ago, to buy a computer, not even talking about a laptop, a computer, you're talking about 5,000-6,000. Now our smartphones are essentially computers in our pockets. We can do anything we want on them, and everybody can get them. So essentially, machine learning is what is going to set us apart from other generations, and what have we been able to accomplish. We are already in the stage of where we're collecting all this historical information, all this data that's driving, the stocks, that drives the what are we producing, why are we producing it, what is the currency, why does it go up and down, all these things that have predictive models already behind them. We'll be able to essentially feed it through a simple program to understand it, really, to get a defined future path of where it could go. I mean, there's never 100%, but this is something that just really enables the everyday user to enjoy the technology as they should. That's it.